What up, you math nerds? Today we're going to cover problem 66 from my book, Book of Antiderivatives. This is a book of 100 antiderivatives that I think are kind of difficult, a little tricky, and require some algebraic work. And if you think you can solve problem 66, go ahead and pause the video and try to solve it yourself. And if you're looking for some sort of integral adventure, you can get this on Amazon or on my website whenever you like. You ready to have fun? Let's go. All right, so the first thing I'm going to do is go ahead and factor this using the difference of cubes. Doesn't look too bad so far, and I know that we're going to have to use partial fractions for this, so let's go ahead and do that now. Now let's work away with those partial fractions. And we know that this whole thing has to equal 6. Let's go ahead and distribute these variables and FOIL that other part. And now I'm just going to go ahead and combine all the coefficients so that I have the A, B, and C's together so I can somehow find the values for those. And seriously, if you see any mistakes, please let me know in the comments below. So because on the right side, there's no x squared coefficients, we know that a plus b has to equal to 0. Same thing goes for the coefficient in front of the x. Negative 2a plus 2b plus c is equal to 0. And for the constants, that has to equal to 6. We know that b has to equal to negative a, so we can convert that second equation into negative 2a minus 2a plus c is equal to 0. And now we're going to work with this equation and this equation and just kind of simplify it a little bit. Nice. We can go ahead and use systems here and get 3c is equal to 6. So c is equal to 2. And I'm going to use the 4a plus 2c is equal to 6 to solve for my a. So a is 1/2. And then that tells me by default that b is going to equal to negative 1/2. All right, let's go ahead and make some space on the blackboard. So now we have this entire integral is equal to 1/2 over x plus 2 plus negative 1/2 x plus 2 all over x squared minus 2x plus 4. Let's go ahead and write the integral, put the dx in there. And I can go ahead and pull out a 1/2 from everything here so that I can make this a little easier for us. So the first integral is going to be 1/2, 1 over x plus 2 dx plus 1/2. Now let me change it. Let's go ahead and do negative 1/2 x minus 4 over x squared minus 2x plus 4 dx. That first integral is pretty simple. It's basically u substitution, and it's going to be 1/2 natural log of x plus 2, so I'm not going to worry too much about that. Now we're just going to focus on this second integral. So I'm going to kind of do some detective work. I know that we're going to make u is equal to x squared minus 2x plus 4, and our du is going to equal to 2x minus 2 dx, or 2 times x minus 1 dx. So what I want to do is kind of have some prep work for that x minus 4. I want to make sure that I have x minus 1 so that we can go ahead and cancel out an x minus 1 whenever we do u substitution. So for that top one, I'm going to go ahead and introduce a plus 3 and a minus 3. The reason for that is because this, what I just circled, is going to become negative 1. Okay, so let me go ahead and rewrite some stuff. I'm going to make this a little smaller. All right, as you can see, I just rewrote that top one, that x minus 1 minus 3. It's literally the same thing still, but I rewrote it because I know that I'm going to use u substitution so I can cancel out that x minus 1. So now what I have is the integral that we found originally, minus 1/2 integral of x minus 1 over x squared minus 2x plus 4, and then minus 3/2 integral of 1 over x squared minus 2x plus 4 dx. Now, where did I get that? Let's go ahead and look at the very bottom. I had the minus 3 that I pulled out from that integral. When I pulled it out, I multiplied by the 1/2, so that's how I got negative 3/2. That second integral, it's already established. So we make u is equal to x squared minus 2x plus 4. du is equal to 2x minus 2 dx. In other words, that's 2 times x minus 1 dx. I can bring it to the other side, so I have du over 2x minus 1 equal to dx. So now what I have is 1/2 natural log of x plus 2 minus 1/4 integral of du over u minus 3/2 integral of 1 over x squared minus 2x plus 4 dx. Type problem just like the first one, except we kind of just skip the whole u substitution. We know how to do that already. So now we have 1/4 natural log of the value that our u value, which was x squared minus 2x plus 4. And then we still have that other integral to deal with, which is our very last one. Let's make it a little smaller. All right, for that last integral, you already know how much I hate this, but we're just going to go ahead and have to complete the square for this so that we can simplify it, and it looks like it's going to be an arctangent type problem. If we use arctangent, our u is going to be x minus 1, du is dx. That's really easy. Our a squared was 3, so then a is going to be root 3. And so now we're going to have our final integral. The 1/2 natural log of x plus 2 minus 1/4 natural log of x squared minus 2x plus 4 minus 3/2 times 1 over root 3 arctangent of x minus 1 over root 3. Don't forget your plus c. My, oh my, how fun.